Hello students, Miss Slyman here. We've got another example, and this example really takes a little bit of thinking about because we've got a ball that's bouncing. Every time it bounces, it comes back 80% of the height from which it falls. So I want the total distance the ball has traveled after it bounces for the 15th time. So let's make a little picture here. So we start by dropping our ball, and it drops down the 16 feet. And then it bounces back up 80%, and then it comes back down from there. And then it bounces back up, not all the way up. It bounces back up 80% of that. So up 80%, and then it comes back down, up 80%, comes back down, and so on, until we have it bouncing for the 15th time. So it comes up on the 15th bounce. So after it's bounced for the 15th time, it would then come back down. So we can have the 15th bounce. So here's my first bounce here, and here's my drop. So notice I have 2 bounces for all of them except the 16. So I'm going to put the 16 by itself. And then I'm going to look at this one. I'm going to look only at the up arrows and double that. So twice the up arrows. So the first up arrow is 0.8 of 16. And the second up arrow is 0.8 squared of 16. So first bounce is 0.8 of 16, so I've multiplied 16 by 0.8 once. By the time I get to the 15th bounce, I'll have multiplied 16 by 0.8 15 times, because that's the 15th bounce. So it's done 80% 15 times. Well, as you might suspect, we've got a geometric sequence here. So I'm going to take 16 plus 2 times U1, 0.8 of 16, times my R value. My R value is 0.8 to the n. So how many terms am I going to have here? First term, second term, third, fourth, etc. I'm going to end up having 15 terms. Minus 1 all over 0.8 minus 1. So I can work this out in my calculator. Of course, this would definitely be a calculator problem. So let's 16 plus 2 times, make my fraction, 0.8 times 16, parentheses, 0.8 to the 15th power, minus 1, close parentheses, over 0.8 minus 1, close parentheses. So after 15 bounces, it's gone a total of 139.5, we'll say, feet. So about 39.5. Okay, the total distance it will travel until it comes to rest. So this is until it comes to rest. Well, we're bouncing infinitely many times until we essentially are adding 0. So I'm going to keep adding 16, so my sum to infinity, 16 plus twice, and now I'm going to do my same calculation, U1, 0.8 times 16 over 0.8 minus 1. Sorry, if I'm going to do my sum to infinity, I'm going to do 1 minus 0.8. All right, so putting this one in the calculator, 16 plus 2 times 0.8 over 1 minus 0.8 And I realize that I left off here times 16. Okay. Ooh, go to. Anytime you get an error, go to. Oh, that's not good. In the bottom there, I should have 1 minus 0.8. Look at the bigger version. 1 minus 0.8. Close parentheses. All right, 144 feet is how far it will have traveled in total. So remember, in total here, we've got to count the distance traveled both up and back down, up and back down. So we end up with 144 feet. If I had room, my answer would be under here, keeping all of my work together. Actually, I'm just going to do that right now because I get the benefit of being able to make my work smaller. All right, you get the point. So I will see you back in class. Oh, sorry, I'm going to tell you, I'm going to let you, excuse me, I'm going to let you look at this pattern 1 on your own. And of course, we'll talk about this in class.